Hey, what's up, Buckaroos? This is Mr. B here. We're on to topic 7-1. We're still going to be talking about quadratics, although we're going to kind of start now actually talking about what quadratic graphs are and parts of the actual quadratic graph. So there's a lot of information here, a lot of factual stuff, and then we'll start getting into some mathematics of it later on down the road. So just remember, a quadratic equation looks like ax squared plus bx plus c equals 0. Remember, that is standard form. Okay, a quadratic function, all we're doing is replacing the 0 with y. So it's y equals ax squared plus bx plus c. Okay, so basically all we did was replace the 0 with the y. So quadratic equation, a quadratic function, two different things. Recall that a function has input values called the domain and output values called the range, okay? And hopefully if you remember your Dixieroid table, domain, input, range, output, those go together when you make your Dixieroid table. Say a quadratic function produces a graph called a parabola. Okay, so we're going to kind of start leaving linear straight lines behind, and now we're going to start introducing you to the world of parabolas. Okay, so a lot of information here. If you need to pause it to write it all down, do so. Otherwise, let's go on to example 1. Example 1 says, given the quadratic function, complete the table, plot the points, and draw the graph of the function. So what I'm going to do here is I'm going to take my input values, put them into x here, and then solve to get my output, okay? So negative 3 squared is 9, minus 4 is 5. Negative 2 squared is 4, minus 4 is 0. Negative 1 squared is 1, minus 4 is negative 3. 0 squared is 0, minus 4 is negative 4. 1 squared is 1 minus 4, which is negative 3. 2 squared is 4 minus 4 is 0. And 3 squared is 9 minus 4 is 5. So let's plot these points. I want you to do that. So pause me, and I'll go ahead and plot them. But I want you to pause me, plot these points. We'll come back and check, make sure we did them correctly, okay? You check me, I'll check you. All right, so welcome back. So negative 3, 5. So 1, 2, 3. 1, 2, 3, 4, 5. Negative 3, 5. Negative 2, 0. Negative 2, 0. Negative 1, negative 3. Negative 1. Negative 3, okay? 0, negative 4, so 1, 2, 3, 4. 1, negative 3, so 1, 1, 2, 3. 2, 0, so 2, 0. And 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, and so if I can make this work, okay, your graph is going to look something like that, okay, just as a rough sketch. That is kind of what our graph should look like. And that, folks, is what a parabola looks like. Okay, it's going to be kind of a curvature to it. Okay, sometimes they'll be more narrow, sometimes they'll be wider. It just depends on your point. Okay, so here. Okay, we're going to come back to our graph and label some of this down here in a minute. But let's talk about important concepts to know. So a vertex is where the parabola reaches a minimum. Okay, and a minimum graph would look like this. Okay, so that would kind of be your minimum. Or a maximum. Okay, a maximum. And just kind of invert that parabola. So a maximum would have a parabola that looks like this. And once again, that would be your vertex. So here, that right here, would be your vertex. And would that be a minimum or maximum? Okay, this would be a minimum. Why? Because this is the smallest x value that this parabola has. That's why we call it the minimum, because it has the smallest x value of all the points on that parabola. It's the smallest one. That's why we refer to it as the minimum. Okay? So then we have the axis of symmetry. It reflects one part of the parabola over the other. Okay, so in other words, the axis of symmetry, okay, and I'm going to do this in a different color, so maybe you'll see it. Okay, in this case, since the vertex is on the y-axis, that's where your axis of symmetry is going to go. Okay, in other words, this side, if you reflected it, it would lay right on top of this side. Same thing here. If we reflected this side, it would just lay right on top of that side. And so that's why that is called the axis of symmetry. Axis of symmetry. It just reflects one side of the parabola onto the other side. Okay, so let's go to the back. If you need to pause me to go back and copy any of this down, make sure you do so. It's a great thing about these videos is you can pause me and rewind me and go back and do stuff. Okay, so example, for each function, find A, the axis of symmetry, B, the vertex, C, and graph it. So here's a formula they give us. This is how we're going to find the axis of symmetry. It's going to be negative B divided by 2A. So here's your A, there's B, there's C. So it's going to be negative 4 divided by 2 times 1. So 4 over 2, which is just 2. So the axis of symmetry here is going to be 2. And so x equals, okay, because that's what the formula is. So to find the vertex, because it's on an axis, okay, so how do we know it's on an axis? Because x equals 2. Does we remember, if you had x equal 2, what type of line is this? It's either going to be vertical or horizontal. What do you think? Okay, it's going to be vertical. So this is a vertical, okay, line. So let's go graph that. Okay, so let's go graph at x equals 2. Okay, here's x equals 2 right here. Okay, oh boy, that was a straight line and a half. Okay, so that is your axis of symmetry, remember? So our vertex, okay, because it's on an axis x equals 2, let's plug in our equation here. Okay, so remember we have an equation up here. It's in standard form. It's our standard function. Okay, so let me start with a different color. We're just going to use this function right here, and we're going to replace it with the number 2. Okay, so it's going to be 2 squared minus 4 times 2 plus 5. And remember, that's y equals. So if you put that in your handy dandy little calculator, you should get y equals 1. Okay, well, now I'm going to figure out if y is 1 and x equals negative 2, the ordered pair for my vertex is going to be 2, 1. Okay, so let's come over here and plot it. 2, 1 is right there. So that's going to be my vertex. Now I've got to graph it. So let's get a couple of points. Okay, and how are we going to get a couple of points? So let's see how we're going to do it. We're going to use our function still. And let's just say if x equals 0. Okay, so we're going to have 0 squared minus 4 times 0 plus 5. Okay, and so that's going to be y equals. So y is going to equal, if you put all that in, going to equal 5. So here's our point. So 0, 5. So let's go graph that. 0, 5. So 0, and then 1, 2, 3, 4, 5. Okay, so now let's reflect that. Okay, let's reflect this over the axis of symmetry. So If it's 2 to the left here, it'll be 2 to the right there, okay? And so what is that point? That point is 1, 2, 3, 4, 5. So there's our couple of points. And so now we can just kind of give a quick sketch, okay, of our parabola. Remember, the green line is our axis of symmetry. Okay, the green line is our axis of symmetry. Okay, the red line is our actual parabola. Okay, all right. I want you to kind of take the lead on number 3. I want you to find the axis of symmetry first. Use that formula located in example 2, negative b divided by 2a, and find the axis of symmetry. So go ahead and pause me, find the axis of symmetry, come back, and I'll do it, and we can check each other. So go ahead and pause me and find the axis of symmetry. So that formula, if you recall, is x equals negative b divided by 2a. So here's my A, here's B, there's C. Okay, so it's going to be negative 2 divided by 2 times negative 1. Remember, it has a negative coefficient, that's negative 1. So negative 2 over negative 2. And so x equals 1. So x equals 1 is going to be our axis of symmetry. So let's go ahead and plot that. X equals 1. So let's see if I can't. Okay, so there's your axis of symmetry. Okay, your axis of symmetry is right there. Now let's find the vertex. So because x equals 1, we're going to put this equation they give us, and we're going to replace x with 1. So y equals negative 1 squared plus 2 times 1. Okay, I don't know why I said negative 1 squared. Oh, because it's negative up there, duh, Mr. B. Okay, y'all got to keep me on the straight and narrow now. Okay, and so y is going to equal, if we just plug this into our calculator, we're going to get y is 0. Okay, so y is 0. So let's plot that point. Okay, so that was 1. So x was 1. So 1 comma 0 is what we're going to plot. So 1 comma 0 is right there. So that's going to be our vertex. Now we just have to find out if that's going to be the minimum or a maximum. So let's find 2 points. So let's just say if x equals 3, just come up with a number, kind of range it from 1 to 10. Okay, so y equals negative 3 squared plus 2 times 3 minus 1. So if you put that in your handy dandy little calculator, you would get y is negative 4. So 3 comma negative 4 is what we're trying to plot. So 1, 2, 3, 1, 2, 3, 4. So 3, 4. Now, if you reflect that, remember the axis of symmetry is a reflection. So if it's 2 to the right of our axis of symmetry, this will be plotted 2 to the left. Okay, and so our parabola would look something like this. Okay, and so therefore this then becomes a maximum. Okay, remember that. So that is a maximum vertex right there. Okay, so we'll go over any questions you might have over any of this next time we do 7-1. So thanks for watching. Like I said, you can always go back and re-watch something, pause something again if you don't have a clear understanding of it. And then always don't hesitate to ask me questions when you get into class if there's something that you're kind of stuck on, okay? All right. Thanks for watching, everybody. Mr. B's out.